so you don't have to do them later because you got other homework to work on. All right, so square and square roots. It says Cam has 135 square feet of carpet to cover the floor of his college dorm. Cam knows that the room is square, but cannot recall the exact measurements of the dimensions of the room. What is the maximum length to the nearest 10th foot the room in which the carpet will fill? So let's draw a picture of his dorm. He's got a square dorm room. Make it a lighter color. We don't know the dimension, so we're going to put x. And if I put x here, I can put x there. Because what do I know about a square? All sides are equal. Could I put x's on all four sides if I wanted to? Yeah, that would have been fine too. I'm just gonna put two of them there. Now, do you know how to find the area for a square? How do I find the area with the two x's there? X times x. You're going to do side times side or side squared for a square. So it's going to be x squared, and he's got 135 feet of carpet. Square feet. 135 square feet of carpet. Hopefully, from your Algebra 1 and Algebra 2 days, you know how to solve this. Square root both sides, yes. So we're going to get rid of the square and the square root. Those are going to cancel each other out. X, you're going to get approximately 11.6 because they said to the nearest 10th foot. Now, how did I get 11.6? I typed it into my calculator, right? I would do 135 and then I'd hit the square root button. You do that, you're going to get 11.6. I knew it had to be somewhere between 11 squared, which is 121, and 12 squared, which is 144. I knew 135 was between those two numbers. So when I did it in my calculator, 11.6 made sense. It's a little closer to the 144 than it is the 121. So it's a little closer to a 12 than it is to 11. So we got 11.6. Square root of a number. These are just a couple of key vocab words. Square root of a number is one of two equal factors of that number. Remember what factors are? Numbers that multiply to give you a number. Well, a square root is when you have equal factors. You've got two of them that are equal factors. That gives you the square root. Now, they don't always have to be integers or whole numbers. Like this one right here, 11.6 times 11.6 is going to give you really close to 135. With rounding, it might be a little off, but it's going to be really close. A perfect square, though, down here, a perfect square is a number that has two identical integer factors. Anybody remind me again what an integer is?
A negative or positive
The 1.5 is an integer?
number. No,
Whole number, good. Negative or positive whole number. So think about that for whole numbers, negative or positive. There's one last thing that you need to remember from Algebra 2 that does not apply in geometry. When we square root both sides, usually your answer would be plus or minus 11.6. But in geometry, do we have the negative distances? No, you don't have a negative room length. You can't go back in time and remake a room or whatever, so you can't. It's got to have positive numbers here. So you still got to remember that positive and negative does mean something. It's just in geometry we don't use it because it's got to be a positive distance. All right, so we want to practice a couple of things that you're going to need to do for square roots. So here's just some example problems. The first one says, between what two integers is each square root? Kind of like what we just did a second ago. 53, let's see, 7 squared would be 49. And 8 squared would be 64, right? So 53 is between those two. So if you had to estimate what you think radical 53 is, about how much do you think radical 53 would be? 7.4? 5 away from 49, and it's 11 away from there. So I would say probably 7.3-ish, but 4 might be close. 3, maybe 2. So you could always double check that on your calculator and see what's the closest. I would go 7.3. but maybe it would round to 7.4.
One thing exactly, or just
We're just estimating on it. Yep. 175, let's see, we have 13 squared would be 169, and 14 squared would be 196. So 175 is between those two. Closer to which number? Closer to 13. I'm thinking like 13.2 probably. Because it's only 6 away here and it's 21 away from this one. So I'm thinking probably about 13.2. I'm guessing somewhere in that area. It might be 13.15 or 17 or something, which would round up to 13.2. Now, a radical expression is not simplified if it has a perfect square factor in it. If you can take out a perfect square, you need to do it. Otherwise, it's not going to be reduced all the way, and some of the multiple choice solutions that you'll see, you won't get it right if you don't pull the perfect square out. 147 doesn't look like that has a perfect square in it, but it actually does. You can actually take out, oh, don't start doing that. You can actually take out a 49. 49 times 3, and 49 is a perfect square. What comes out of the square root when you have radical 49? 7 does, because 7 times 7 is our 49. So this is just going to be 7 radical 3 right there. That's how you want it. You want the smallest possible radical you can get. So always try to break them down. This one gets a little trickier because you've got your x to the 4th, you've got your y to the 3rd. I could break down radical 180. I'm going to give you a hint. 4 would work, 9 would work, but what's 4 times 9? 36 would be your best one, and that is a perfect square. So I would do radical 36 times radical 5, and I would leave the x to the 4th, because what do you think the square root of x to the 4th is going to be? Just x squared. It's going to come out, because x squared times x squared is x to the 4th. So right now, I know that a 6 is going to come out, and I know that an x squared is going to come out. I know that a 5 is not coming out, because a 5 is going to stay in the radical. I just got to figure out this y cubed, radical y cubed. Could I pull out a perfect square? I can pull out y squared, huh? So this could be radical y squared times radical y. And what is radical y squared? Just y. So that's going to come out, and one of them is going to stay in. This radical, yeah, the 5 stays in.
Yeah, but what about the other one?
This y comes inside. This y right here, the square root, cancels out the square. So all you have left is a y that comes on the outside. Yes, you're adding. Remember, you're adding the exponents when you're multiplying them. So yeah. Last one here, I would probably do 100 first, because that would be an easy one to take out. 100 times 126 would be 12,600. And we know that 100 is a perfect square. It's a 10. But is there another perfect square that can come out of 126? And the answer is yes. 9 times 14. So what's going to come out of that 9? 3 and times radical 14. So I have 10 times 3 out front. So I got 30. 30 times radical 14. So if 30 comes out, what could have actually come out of 12,600? 30 times 30? 900 could have come out. 900 times 14 would be 12,600. But we'll leave it as, we broke it down a little quicker there that way. All right, so that was simplifying. Now we can also add, subtract, multiply, and divide radicals. We got to know how to do that, especially as we get to right triangles and trig and Pythagorean theorem and all that stuff. So let's talk about radicals with like terms first. That's putting them together. So if I had, let's say I had 2x minus 6x plus 3x, which is basically the same thing I have right here. If I combine my like terms, That would give me a negative 4x plus 3x would give me a negative x. Does that make sense? We're just combining like terms? That's all you're doing here. You're putting your radical 15s together as like an x. So you've got 2 radical 15 minus 6 radical 15 would give you negative 4 radical 15 plus 3 radical 15. Now you put these two together and you're just going to get negative radical 15. Could I put negative 1 radical 15? I could. Negative 1 can go in front, but I don't need to.
Anything inside the radical? No.
You don't do anything inside, just like an x. Unless you can pull a perfect square out. But 15, there's no perfect square that comes out of 15. So that would be a negative. Radical 180. We just broke that down a second ago. Do you remember what we broke it down into? 36 and 5. So 36 times radical 36 times radical 5 is going to give me 6 radical 5. Radical 320, I'm going to give you a hint. It's going to be radical 64 times radical 5. So what am I going to have down here that I'm going to add to 6 radical 5? 8 radical 5. So that's going to give me, oops, not 15. It's going to be 14 radical 5. You see how I got the 14, the 6 plus the 8? All I did was I combined 6 and 8 together, and I got radical 14, 14, and then the radical 5 stays in there, just like an x. You're just combining like terms, leaving your like terms. Multiplying radicals. Let's take a look at this one right here. 2 radical 5 is already reduced. Radical 45 is not. You could actually break that into radical 9 times radical 5. So I'm going to get 2 radical 5 times 3 radical 5. How do I multiply those two together? 2 radical 5 times 3 radical 5. It would be 6. You've got 2 times 3 is going to give me 6. And what's radical 5 times radical 5? Radical 25. But we don't want radical 25. So it's just going to be 6 times 5, which is 30. So what happened when I did radical 5 times radical 5? I got 5. So if I did radical 2 times radical 2, you get 2. Radical 8 times radical 8, you get 8. So when you multiply the same radical together, that number comes out. And that's what we're going to use. We're going to use that information to apply to this one. Rationalizing the denominator means you get rid of any radicals down here. You can't have radicals on the bottom. Remember how we can't divide by 0? You could also say, thou shalt not divide by a radical. You know why you can't divide by a radical? Because you don't know how much that number actually is. Radical 2 is about 1.4. But does it ever actually end? No, it goes on forever. And it never stops. And it does not repeat. So you really don't even know how much that actually is. You can't divide by something that you don't know how much it is. So you can't divide by radicals on the bottom. You've got to get rid of those from down there. To do that, I'm going to multiply by 1. But I'm going to use the form of radical 2 over radical 2. That is still equal to 1. Radical 2 over radical 2 is equal to 1. And anytime I multiply by 1, it stays equal. Now I can just multiply straight across. Radical 6 on top and a 2 on the bottom. That is completely reduced. You cannot reduce the 6 and the 2. Why? 6 is in the radical, 2 is not. You have to have them either both outside or both inside. You could then divide them if you had to. That's not going to. Yeah, but if you had radical 6 over radical 2, you could make one big radical of 6 over 2. And then you would get radical 3 right there. That does not have a radical on the bottom. If you had 2 radicals, you could put them under one radical. If they will divide, then you're good. If they won't divide, then you have to do this. Because now radical 3/2 wouldn't come out, so I had to break it down into that. Unless they'll come out, yeah. On this one right here, I'm going to put an x radical 11y. Does anybody know why I could do that? What is x cubed? X cubed would be radical x squared times radical x, right? What can come out? An x. What has to stay inside? Oops, sorry. An x. So yeah, it's got to be 11xy, my bad. On the bottom, see if you can figure out what I'm going to do here. I'm going to put a 2, an x squared, a radical 3y. How did I get that? 4 times 3, so radical 4 would be a 2, right? And then my radical 3's got to stay. Square root of x to the 4th, x squared, it comes out. And then the y has to stay inside. Could I reduce the x's now that they're both on the outside? Now that they're both on the outside, I can get rid of one on the top and I can get rid of one on the bottom. I need to get rid of this radical down here. So I'm going to multiply by the 3y on top and bottom. That is the same thing as multiplying by 1. So I can take that out. So the bottom of my fraction is going to be 6xy. Does anybody see how I got that? When I multiply these two, I get 3y and I get my 2x. That's how I get 6xy. Radical 3y times radical 3y is 3y. And then 2x here times 3y gives me 6xy. So that would be the bottom. The top of my fraction is going to be 33. The y is going to come out, because what's y times y? Y squared, and that's going to come out of the square root. And you're going to get 33x inside. Can I reduce one last thing? There's a y on the outside, and there's a y on the outside there too. So radical 33x over 6x, can I reduce those x's? No, one's inside, one's not. You got to leave them. So that would be your final answer there. Radical 33x over 6x. Just leave it. That's done. Can't reduce that anymore. That's probably way more detailed than we're going to need to get to in geometry. Maybe even in trig. We might get to a little something like that, but that's probably even more detailed than we need. Okay, the last couple here really fast. I'm just going to do these top two right here, and then I'll leave the bottom. I don't need it. This one right here, I need to multiply by the radical 3 on top and bottom. So I'm going to get 18 radical 3 over 3. 75 is going to be 25 times 3. So I'm going to get plus 5 radical 3. What's 18 divided by 3 right here? 6 radical 3 plus 5 radical 3. These are like terms, so you get 11 radical 3. Two radical 14 is going to come down. This is going to be radical 4 and radical 2, so this is 2 radical 2. Plus, this is going to be 2 radical 7. Here we're going to get 4 radical 28 plus 2 radical 7. Radical 4 times radical 7. So you're going to actually get 8 radical 7 plus 2 radical 7. You get 10 radical 7. And I won't do the bottom one. Give you those. Now I need to give you your homework, your starter homework.